Adding and subtracting radicals. So what's really important in this lesson, exactly like polynomials, is having the ability to identify what is a like radical and what is unlike. Very similar to polynomials. We can do addition and subtraction with like terms, and if terms are unlike, you cannot combine them in any meaningful way. So when adding and subtracting radicals, only like radicals can be combined. You may need to convert radicals to take a different form, either mixed or entire, before identifying like radicals. So here I think it's always advantageous to simplify radicals. So maybe I should say, what's a like radical? Well, like radicals are radicals with the same radicand and the same index. So let's just go on to our first example here. Example A, 5 root 6 minus 2 root 6. So allow me just to explain to you why these are like, because the index of both these radicals is 2, and the radicand is 6. Now, analogously, maybe this is just going to help our conversation. Suppose if I had 5x minus 2x, what is that result? Well, that would be 3x. Now, notice that you didn't do anything with the x's or the exponents. It was just simply, you did the integer math of 5 minus 2, and really the variable x was along for the ride. Well, here, similarly with radicals. 5, the square root of 6, minus 2 root of 6 is going to be 3 root of 6. Fair enough. It seems easy. Now, for B, 8, I'm just going to maybe look at my radical here, and I notice that it's the cube root of 5. So 8 times the cube root of 5 plus 3 times the cube root of 5. So since the radicands are the same and the indexes are the same, these are similar radicals. So 5, the cube root of 5 plus 3 root 5 is going to be 11, the cube root of 5. Not so bad. Now let's mix it up a bit. At first glance, this seems like these are unlike. However, I wonder if there's a way to make them like. And if I'm looking, I can recall my skills of simplifying radicals. Fair enough. So the square root of 50, I'm going to try to simplify and see what comes up. May I suggest, I have a strong feeling that it's going to simplify into the radical root 2. But let's see that journey. So root 50, I would decompose this in the following way. I asked myself, does there exist a perfect square that is a factor of 50? Yeah, definitely. And that's 25. 25 times 2. Plus 3 root 2. I get to simplify my radical on the right-hand side. And this is 5 root 2. Oh, pardon me, I may have skipped a step there. It simplifies into the root of 25 times the root of 2 plus 3 root 2. Now 25 root 2 simplifies into 5 root 2 plus 3 root 2. So 5 root 2 plus 3 root 2, we get to a place where we can say, our radicals are like, so we get to combine them in a meaningful way. So 5 root 2 plus 3 root 2 is going to be 8 root 2.